All right, hello again. Section 11.2 is the quadratic formula. Quadratic formula in some cases is the only method you can use to solve some of these equations. Some of these you can graph. You can see where the intercepts, the x-intercepts are, and those are your solutions. But if these things are imaginary solutions or radical form, there's just no technology that you can really use very well to come up with these. Quadratic formula, given ax squared plus bx plus c equals 0, where a, b, and c are numbers, constants, then x is going to equal the two solutions, the opposite of b plus or minus, plus this thing divided minus this thing divided, those are your two solutions, plus or minus the square root of b squared minus 4ac, all divided by 2a. The b squared minus 4ac is the part under the radical. That's called the discriminant. You can tell a lot about a function by looking at that term. If the discriminant is positive, there's going to be two real solutions. You can square root a positive number, and you'll have both a positive and a negative. If it's 0, then that part just drops out, and you only have one solution. But if it's negative, you're going to end up with some imaginary solutions, complex numbers, actually. That's because the square root of a negative leads you to the imaginary unit. I've got a couple of examples here. These both, I checked, they both work out quite ugly, which means that there's no factoring that you can do or anything else to expect this to work out nicely. So let's go ahead and solve this. The best thing to do, you notice that it's set equal to 0, you got to move everything over to the one side to solve this. So I'm going to subtract 6x and add 1 to both sides. 2x squared minus 6x plus 1 equals 0. And then x is going to equal, sometimes it's useful to write down a little key. A equals 2, b equals negative 6, and c equals 1. So x is going to equal the opposite of b. The opposite of negative 6 is 6, plus or minus the square root of b squared, negative 6 squared minus 4 times a times c, all divided by 2a. 6 plus or minus 36. 4 times 2 is 8, times 1 is 8, so it's 36 minus 8. Be careful about that in there to make sure that you do that subtraction, multiplication stuff correctly. 2 times 2 is 4. 6 plus or minus 36 minus 8, would that be 28? Square root of 28 over 4. I see a perfect square that lives inside 28. That would be 4 times 7. The square root of 4 is 2. So this becomes 6 plus or minus 2 square roots of 7 divided by 4. You notice that there is an even number that can be factored out on top, canceling with the even number down below. 2 times 3 plus or minus the square root of 7 over 4. 2 times 3 is the 6. 2 times the square root is 2 square roots. Now this 2 cancels with the 4, leaving a 2. That would be 3 plus or minus the square root of 7 over 2. You can leave it like this as a single fraction, and it works, or you can separate that into two separate fractions. So that's the process. Let's do it with this one down here and see if it will look any better. I'm going to add 6x to both sides, so I'll have 3x squared plus 6x plus 5 equals 0, where a equals 3, b equals 6, c equals 5. Everything's positive here. So x is going to equal the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. That's negative 6 plus or minus 36. Let's see, 12 times 5 is 60 divided by 6. Let's see, that's going to equal up here. Negative 6, what is 36 minus 60? Would that be 24? Negative 24 over 6. Negative 24 has, again, that 4 as a factor inside of it. So that becomes a 2, but there's also a negative 1, which comes out as an I. So this is 6 plus or minus 2I square roots of 6 divided by 6. In this case, I can again factor out a 2. I'm running out of room. I should rearrange my basement just for all of you. Equals 2 times negative 6 plus or minus I square roots of 6 divided by 6. The 2 cancels with the 6, leaving a 3. This is negative, oh, that's a typo. That should be a 3. I'm not editing that out. You can follow it. That's going to be negative 3 plus or minus I square roots of 6 divided by 3. And that is the answer. Phew! These get pretty ugly pretty fast. Hopefully there's not too many that are as ugly as this. If you have any thoughts or questions or want me to work through one with you that you're struggling with, click that question help with the Ask My Instructor, and it sends me an email right away. So rock on all.